Alright, Algebra 2 fans, Section 1.5, absolute value equations. This is only part one of the video because the second half of the video is involving the absolute value inequalities. Your absolute value equations will be on your quarterly exam, so we want to make sure we cover this material so we're ready for that exam that's coming. What is absolute value, or what is the absolute value of a particular number? It is, in simple form, the distance away from zero. The distance away from zero. So when we start asking you questions like what's the absolute value of -5, we're looking for its distance away from zero. Obviously on a number line you've got -5 and you've got 0 and there's a distance in there, right? And so you can tell me that it's 5 units away. What if I had a simple question like this? Solve the absolute value of x equals 3. Now here's an equation, a very simple equation. So the number that would work for x would be any number that's 3 units away from 0. Any number that's 3 units away from 0. Obviously, there are two numbers in the universe that are 3 units away from 0. X equals 3 or x equals -3. Those are the two solutions that would make that a true statement. To continue with that logic, we're going to get into slightly more difficult problems, such as this particular example. Now, I'm going to cover up what's underneath the parentheses, or the absolute value bars, I'm sorry. So whatever is under my thumb, we're going to take the absolute value of that, and that equals 12. Now, what could that number be? Well, the number under my thumb could be 12, or it could be -12. So I'm immediately going to split this up into two different equations. 2y minus 4 could be equal to 12, or 2y minus 4 could be equal to -12. Now the only reason we could do that little trick was because the absolute value bars were isolated. That means they were by themselves. Absolute value bars were isolated. And what do I mean by that? I mean there's nothing that's being multiplied times this. There's nothing being added or subtracted to this. These absolute value bars are all by themselves. That's not true for the next example. Notice that it's got a 3 and a -5. Those mean that that is not isolated, and we'll have to take care of those first when we get to that question. Alright, now to finish this particular question, yes, we're going to be adding 4. So 2y will be 16. Yes, we'll be dividing by 2. So y equals 8. And so we'll add 4 over here, and that gives me -8. 2 divided by 2, y equals -4. Now, a lot of kids get the idea in their head that when they're solving an absolute value equation, then they get one answer, and then they just assume that the other answer must be -3. If that one's +3, the other one must be -3. So they just put plus and -3. Well, that works out fantastic in this particular example. But if you get 8 and just assume that the other answer is -8, you will be wrong. So I don't want you to be wrong. Okay, so I want you to solve both equations to find the two possible answers. Now, as I said earlier, from this example, you can clearly see that the absolute value bars are not isolated. So my first question to you, or my first thought is, we need to get those things isolated. So we're going to move that to the other side, right? We're going to add 5. So now I have 3 times the absolute value of 4w minus 1 equals 15. And then we're going to divide by 3. You know what a very common mistake for a lot of kids is? A lot of kids would distribute that 3. Don't be that person. Okay? Don't be that kid that's going to do that. There are going to be those kids that decide to distribute the 3. There is no distributive property across absolute value bars. So this idea of distributing it in is no, 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 no. We are not going to do that. Okay? Do you like the hand motions? You know, while I said no, 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 no. That's for the people who are not paying attention to me. Okay? So I divide by the 3. That gets me my 4w minus 1. Isolated alone, and that's equal to 5. Now I can split it up into 2 separate equations. We lose the absolute value bars when we split this up. I hope you've been realizing that as we go through. As soon as you get to this part and you split it up, 4w minus 1 equals 5, or 4w minus 1 equals negative 5. You'll notice that the absolute value bars have disappeared. Okay, and then of course we're going to add 1. 4w equals 6, add 1. 4w equals negative 4. And solve. W equals negative 1, or W equals 1.5. When you divide 6 divided by 4, you get 1.5. Now, this phrase, extraneous solution. There's your $15 phrase that you'll use at your next party, I'm sure. Extraneous solution. You can see the word extra in there. The word extra is trying to indicate to you that the solution that you found is not a true solution. Now, the only types of problems where you really have to worry about this are ones where you have variables on the outside of the absolute value bars. See, I see right here, I see a variable on the outside of the absolute value bars. Now I've got to be concerned, because there's a possibility this will always be positive, and this could be negative, and then I'd have a problem. So I'm going to do all the math, and then I'm going to see if either of the possible answers that I get ends up being an extra one that is not true. So, first question again, are the absolute value bars isolated? Answer, yes. Okay, so that's good news for me. So I can immediately go to splitting this up, right? 2x plus 5 is equal to 3x plus 4, or 2x plus 5 equals, now I want you to be real careful here. Remember how we've been taking the opposite? Like right here we had 5 over here and negative 5 over there. The same logic is going to hold true. We had 3x plus 4. Now we're going to have the opposite of 3x plus 4. Now I'm writing it above where I'm going to put so that you can see. I'm going to distribute those, and I'm going to write negative 3x minus 4. I wanted to write negative 3x minus 4, but I wanted to show you why I did that, or how I got it. I didn't want to just say negative 3x minus 4 and have you all look at me and go, where'd you get that from? So just keep in mind, I took the other side here, and I want the opposite of that. So now I'm going to go through the process of solving, right? We move our variables to one side and our constants to the other. So subtract a 2x and subtract a 4. That was pretty easy. And add a 3x and subtract a 5. And divide by 5. X equals negative 1.8. So I'm going to go back to the original statement up at the top here. 2 times 1 plus 5 equals 3 times 1 plus 4. We're going to plug in one of the solutions and see if it works. So we have 2 plus 5 is 7, so we have the absolute value of 7. 3 times 1 plus 4 is 7. That's a good solution. Okay, that worked out. Absolute value of 2 times negative 1.8 plus 5 is equal to 3 times negative 1.8 plus 4. So let's see here, we've got, that's negative 3.6 plus 5, absolute value 1.4. And on the other side I have negative, what's that? Oh, I should know this one. 1.8 times 3. You got 5.4. Negative 5.4 plus 4. That's a negative 1.4. Nope, not going to work. Not equal to each other. So this is extraneous. This fits that definition. Now for all these problems, and we'll practice them in class, I'm going to ask you for the possible solutions, the extraneous solutions, and the actual solutions. Now in this particular example, we found out that 1 and negative 1.8 were the possible solutions. When we did the math, we found out that negative 1.8 was an extraneous solution. So we found out that 1 was the only actual solution. Let me show that to you again. So possible solutions were 1 and negative 1.8. The extraneous solution we found was negative 1.8, so that left the actual solution to be 1. Now there are occasions where both solutions are good. You will have no extra solutions or no extraneous solutions, and you will write the word none right there. There are times where both solutions are extraneous. Therefore, the only actual is, then there's no actual answer, so you write none on that blank. So there are times where we might have to write this word none. And I'm sure we'll come across some of those examples. But you need to be prepared to write down all the possible solutions, then actually plug them in to find out if there are any extra ones or extraneous, and then find out the only ones left that are actually good solutions. All right, we'll practice more in class.